Imagine a planet drifting through the endless darkness of space, completely untethered to any star. This is not science fiction. It is reality. Meet Chi 1107 7626, a rogue planet that has stunned astronomers with its explosive growth. Observations show that this planet is absorbing billions of tons of gas and dust every single second, steadily increasing its mass. But why is this happening? How does a rogue planet like CHA 1107 7626 grow in isolation, far from any stellar system? And what does this tell us about the formation and evolution of planets across the galaxy? Today we will explore the extraordinary journey of CHA 1107 7626 and discover what makes this rogue planet unlike anything else we have ever observed. Rogue planets are celestial wanderers that drift through space without orbiting a star. Unlike Earth, Jupiter, or any other planet in our solar system, these objects are completely isolated, making them extremely difficult to detect. The discovery of CHA 1107 7626 challenges our understanding of planetary formation, showing that planetary growth can occur under extreme, unexpected conditions. Astronomers have used a combination of space-based and ground-based telescopes to study this mysterious planet. The Hubble Space Telescope provided high-resolution images of the nucleus and surrounding dust, while the James Webb Space Telescope revealed its chemical composition in unprecedented detail using near-infrared spectroscopy. Ground observatories like the Gemini South Telescope in Chile have complemented these observations, capturing the comet-like tail and light-scattering properties of this rogue planet. The growth of CHA 1107 7626 is extraordinary. Observations show that the planet is absorbing billions of tons of interstellar gas and dust every second, a rate far higher than initially expected. This accumulation of mass may push the boundaries between planet and small star, blurring the lines of classification. Hubble images captured the shape of the nucleus and the teardrop formation of dust being ejected as the planet absorbs surrounding material. Based on these observations, scientists estimate the planet's diameter to be between 3 and 10 kilometers, though mass accumulation is ongoing, and these values may evolve with further measurements. James Webb spectroscopic data show a complex coma structure, with carbon monoxide and carbon dioxide being released at a faster rate than water or hydrogen at this stage. This indicates that the planet's outgassing processes are highly dynamic and may change as it interacts with interstellar material. Observations from the Transiting Exoplanet Survey satellite TESS revealed that CHA 1107 7626 is far more luminous than expected for its size. The planet's brightness increased dramatically over a period of weeks, a clear sign of intense activity. Measurements suggest that the planet's energy output surged by a factor of 5, far beyond the expected factor of 1.5 from its proximity to interstellar gas clouds. This unexpected activity demonstrates that CHA 1107 7626 has been active even when located far from nearby stars, absorbing volatile materials that sublimate and create a glowing coma. Ground-based telescopes observed a tail forming behind K 1107 7626, extending over a significant distance similar to a comet in our solar system. This tail is composed of gas dust and ice particles being pushed away as the planet absorbs interstellar material. The tail shifts and glows as the planet rotates, creating a dynamic spectacle that challenges our understanding of isolated planetary behavior. Polarimetric studies revealed that CHA 1107 7626 has a deep and narrow negative polarization. This means the light it scatters behaves in a way never seen before for any comet, asteroid, or rogue planet in the galaxy. This unique scattering pattern may indicate unusual dust grain structures or a completely novel surface morphology. making CHA 1107-7626 one of the most intriguing small planetary bodies ever studied. Rotational studies suggest a spin period of approximately 16 hours, although the data remains noisy and subject to verification. The planet's rotation affects how material is ejected and how the tail forms. The interplay between rotation and outgassing creates an ever-changing appearance that is difficult to capture in a single observation. Spectroscopic analysis revealed the presence of cyanide molecules emitted as water and other volatile compounds sublimate under sunlight. These molecules break apart into hydrogen and nitrogen, creating a complex chemical environment in the surrounding coma. Interestingly, CHA 1107-7626 is carbon chain depleted, producing fewer C2 molecules relative to cyanide than typical comets. This feature is shared only with interstellar comet Borisov, suggesting that rogue planets may have unique formation histories and chemical compositions, distinct from planets or comets that form within star systems. James Webb Space Telescope observations also detected carbon monoxide and carbon dioxide being released at higher rates than water at this stage. The planet's outgassing is highly dynamic and changes as it interacts with surrounding interstellar material. This creates a glowing coma that shifts in intensity and structure as the planet drifts through space. Amateur astronomers and professionals alike have noticed changes in the planet's color and brightness, indicating that outgassing may also produce chemical reactions in the coma. These reactions could temporarily alter the light reflected and scattered, making CHA 1107-7626 appear to change color over time. Observations suggest a greenish hue, which may be caused by energized diatomic carbon fluorescing when exposed to sunlight. This is unusual because the planet is carbon depleted, making this phenomenon especially intriguing. Every new observation provides insights into the extreme physics of rogue planet evolution. The combination of tail formation, rotation, polarization, and chemical composition creates a complex puzzle that challenges our understanding of planets evolving far from stars. This knowledge is critical to understanding how isolated planets can survive and grow. In the harsh environment of interstellar space, CHA 1107-7626 provides a rare opportunity to study planetary growth in isolation. Its explosive mass accumulation and unusual chemical properties challenge current models of planetary formation, highlighting the diversity of processes in the galaxy. Polarimetric, spectroscopic, and tail analyses all indicate that rogue planets may form under extreme conditions and could be more common than previously thought. Each new observation brings astronomers closer to understanding how such planets survive in interstellar space and how they interact with surrounding gas and dust clouds. The planet's carbon chain depletion and unusual cyanide output suggest that its formation may have occurred under conditions very different from planets formed around stars. This raises questions about the early universe and the processes that produce free-floating planets. These objects may be remnants of early star systems or products of violent ejections from young planetary systems. The explosive growth of CHA 1107-7626 also highlights the potential for rogue planets to reach masses comparable to small stars if allowed to accumulate material for long periods. This blurs the line between planet and star, creating challenges for classification. Astronomers are keen to observe whether the planet will continue to grow at its current rate or whether it will stabilize once surrounding gas and dust are depleted. Future observations are planned with space-based missions like SOHO Sphere-X MAVEN and continued tracking with Hubble James Webb and Gemini Observatory. These missions will allow scientists to monitor changes in brightness, chemical composition, tail formation, and rotational dynamics over time. This is crucial because rogue planets like CHA 1107-7626 evolve in unpredictable ways, and real-time data provides the best opportunity to understand their behavior. Speculations have also emerged about whether rogue planets could harbor conditions suitable for unusual chemistry or even prebiotic molecules, despite being far from any star. Without sunlight, the chemistry would rely on outgassing internal heat and cosmic radiation, creating a unique laboratory for astrochemistry. The study of CHA 1107-7626 could therefore inform scientists about the potential diversity of planetary environments in the galaxy. Amateur astronomers have also contributed observations, capturing changes in brightness and color. These contributions complement professional studies and show that the universe is accessible to anyone with curiosity and a telescope. Every new image and measurement adds to the puzzle of understanding. Rogue planets, as CHA 1107-7626, drifts through interstellar space. It leaves many questions unanswered. How long has it been traveling? How did it achieve such explosive growth? What will happen as it continues to accumulate mass? Could it someday become massive enough to ignite fusion, or will it remain a planetary body? These questions drive scientific inquiry and inspire future research. The study of CHA 1107-7626 reminds us that the universe is far more dynamic and surprising than we often imagine. Its explosive growth, unique chemical makeup, and unprecedented polarimetric properties challenge our understanding of planetary formation. Observing rogue planets in real time opens a window into a universe full of mysteries and unexpected phenomena. The story of CHA 1107-7626 does not just deliver facts. It sparks curiosity, wonder, and awe, showing that the cosmos is constantly evolving, and that every new discovery has the power to reshape what we know about our galaxy. As scientists continue to monitor this rogue planet, one thing is certain: the universe is alive with phenomena waiting to be understood. And CHA 1107-7626 is a perfect example of that mystery. Imagine drifting alongside CHA 1107-7626 through the endless darkness of interstellar space. The planet glows with a faint green hue from energized diatomic carbon, reflecting sunlight from distant stars. Its tail stretches behind it like a cometary banner, twisting as the planet rotates and absorbs interstellar material. Millions of tiny dust particles orbit and scatter light, creating a shimmering halo around the planet. This is a cosmic ballet occurring far from any star, yet full of motion and energy. The explosive growth of CHA 1107-7626 is not just a curiosity, it is a reminder of how dynamic and mysterious the universe is. Every observation from Hubble, James Webb, TESS, Gemini, and ground telescopes builds a more detailed picture, revealing how planets can evolve independently and challenge what we thought possible. Observers capture the glow, the tail, the chemical emissions, and the spinning motion, creating a story of physics, chemistry, and celestial mechanics unfolding in real time. Scientists speculate about the long-term evolution of rogue planets like CHA 1107-7626. Will it continue to grow until it becomes a brown dwarf, or will it stabilize as a massive isolated planet? The chemical reactions in the coma and tail may produce unusual molecules or reveal conditions that are rare in the rest of the galaxy. Polarimetry shows how light interacts with dust grains, hinting at processes we cannot recreate in a laboratory. Each new discovery pushes the limits of our understanding and invites more questions than answers for viewers and space enthusiasts. Visualizing CHA 1107-7626 can spark imagination. Picture billions of tons of gas spiraling toward the planet, colliding and releasing energy, forming a glowing envelope of light. Picture the subtle green hue changing over time as carbon compounds fluoresce. Picture the comet like tail bending and twisting, reflecting the planet's rotation and interactions with interstellar winds. This is not just science. This is a cosmic story unfolding in the universe, and we have the privilege to witness it. Amateur astronomers have joined the professional efforts, capturing images and reporting brightness changes, adding valuable data to scientific studies. This shows that curiosity, exploration, and observation are not confined to laboratories or universities. The universe is accessible to everyone who looks up and wonders as Che 1107-7626 drifts through space. It leaves a legacy of questions. How did it form? How long has it traveled? How unusual are rogue planets in the galaxy? Could other rogue planets also be growing explosively without our knowledge? Observing this planet teaches us to expect the unexpected and to continue exploring with open minds and instruments ready to capture the unseen. Every telescope, observation, every spectrum, measurement, every polarimetric study, and every amateur image contributes to a larger understanding of rogue planets and interstellar objects. Each piece of data is a clue guiding astronomers to unlock the mysteries of planets without stars. Che 1107-7626 is a perfect example of the wonders of exploration and the surprises that the cosmos holds for those willing to look. The universe is full of phenomena waiting to be understood. And Che 1107-7626 is a vivid reminder that even in the darkest emptiness of interstellar space, there is motion, there is growth, and there is discovery. Every new insight helps us map the cosmos more accurately. Every new observation fuels curiosity and imagination, reminding us that the universe is alive with activity and full of mysteries yet to be revealed. So as we watch Che 1107-7626 drift silently through the galaxy, we are not just observing a planet. We are witnessing the extraordinary dynamic processes that govern the cosmos. The rogue planet may be alone in its journey, but it is connecting scientists and space enthusiasts across the world, inspiring awe, wonder, and a deeper appreciation for the boundless mysteries of our universe. Che 1107-7626 drifts silently through the galaxy, a mysterious, rogue planet defying everything we thought we knew. Its secrets are still unfolding, and the universe is quietly daring us to discover what comes next. Thanks for watching.